Um, Great. So yeah, we're here. I'm going to talk about some of the updates that we're making right now to kURL, which is our embedded Kubernetes cluster distribution. I'm going to split the time a little bit with Chris. I'm going to spend a lot of time talking, or a little bit of time talking, showing some slides and kind of explaining what we're doing. But the fun part's going to be the second half here, where Chris is going to show a couple of demos of installing the updated version of kURL. Before we dive in, like there's been a little bit of kind of naming that we've been talking about here. Helm VM has shown up a few times in some previous talks. Uh, Helm VM is just the internal name that we were using as we were building this out. This is, we do intend this to be a replacement for kURL, and we'll talk about the status of it and what it is. But first, like why? Why are we making some updates to kURL? We've basically, we've kURL's been around for a little while. It works really, really well, but we've listened to some feedback as Kubernetes has changed, as the ecosystem has changed, and requirements have come in and changed. We've heard some common threads, and I'm going to dive into each of these, but specifically, host dependencies get to be cumbersome. Some types of installations require a little too much Kubernetes knowledge and expertise by the end customer who's actually operating it. Installations can take a long time. The upgrade experience isn't really where we want it to be, and there's no really good way to reset and start over. Diving into each of these, host dependencies. So right now, we package all host dependencies with kURL. So if you have a customer who's going to run it in an air-gapped environment, they download a rather large tar gzip that contains all the host dependencies for all the supported operating systems. This creates a couple of challenges. One, that really large tar gzip continues to get really larger. As we're adding new operating systems in and new versions of Kubernetes in, it's just getting to be a huge, huge bundle to download. And when you have a customer who has a new operating system that we don't yet support, the host dependencies that are in there just to run Kubernetes aren't going to work on that operating system. So you have to wait for Replicated to add support for that operating system in. And we have a wide range of operating systems that we support, but we're always going to be playing catch up to what's the newest version of RHEL or Debian or Ubuntu that end customers might want. Kubernetes knowledge is needed a little too much for end customers. For a single node install, it really works great. You just download that large bundle and install it, and really there's no Kubernetes knowledge needed. It's a curl pipe sudo bash, and then customers running the application with Kubernetes. But then installations get more complex. You get to high availabilities installations that have external load balancers. That adds another layer of complexity and configuration in. Distributed storage, where you need Rook and Ceph configured across multiple nodes, and you need to bring additional block devices or disks to them, and how they get mounted adds more complexity. And then, the highest level ones are where you have really large installations where you want the Kubernetes control plane and the worker nodes running on different compute with taints, tolerations, and labels. And then that gets to be more. So what you end up with is these really large, complex installations work with kURL, but the end customer who's running that installation has to know a little bit about how Kubernetes works. And it's more than we actually want to do. We want this to be easier to run. Next step was that installations could take a long time. kURL today is based on kubeadm, and an installation on that first node can take 15 minutes. And it's scripted, so it's not like a lot of interactive 15 minutes, but 15 minutes is not super quick. And it's even more frustrating if an error happens towards the end of that process, then that feedback loop is just too long. And so we wanted to address that. We have two more things. One is the upgrade experience. We've delivered an admin console that you click a button to upgrade the application, but the infrastructure is a separate upgrade process. And that generally requires SSHing into one or more than one node and running kURL commands to upgrade the infrastructure. So what that means is you have kind of a disconnected and a decoupled upgrade experience from the application and the infrastructure. And if you have a lot of customers, the end result of that is you're going to end up with customers who maybe only run the app upgrade and not the Kubernetes cluster upgrade, and they're a little hesitant to do that, or they forget to do it. And then you end up with a variety of infrastructure and applications that maybe hasn't been totally tested, those versions together. So we want to make that upgrade experience a lot easier. And the last part was there's no good way to reset. This might not sound like a big problem for folks who are using the cloud, because if you have an EC2 instance or a GCP instance and something went wrong and you want to start over, you just delete it, create a new one. 30 seconds later, you can start over. But a lot of larger enterprises, still have systems where it might take them weeks and honestly even like months to provision a VM. So if something went wrong during an installation, start over, that can start to be the point where it adds a week or months onto an installation process, which is pretty extreme. So what we've been working on is an update to kURL. So I'm going to call this kURL 2.0 right now, and it's currently in preview, and we attempted to address those problems and some more. I'm going to walk through how, and then we're going to get to the fun part of the demo. Host dependencies are no longer a problem. Instead of building on kubeadm, we're building on K0s. And this gives us a statically compiled single white labeled binary. Statically compiled being key here. A new operating system, we don't have to bring host dependencies into it. It won't get larger and larger anymore. And you'll see in the demo, it's a single binary and it's white labeled to be your application name. It's not Kubernetes, it's not K0s or anything like this. It's the application name. Kubernetes knowledge is no longer needed. We're really focused on delivering an appliance-like experience from end to end. So instead of, is this a Kubernetes control plane, a block device that I need to bring in, or a worker node, we're focused on delivering application-defined labels. Maybe this is a job runner. Maybe this is, you define what those labels are, and those translate into labels that go on nodes and workloads to run it. We're working on multiple ways to manage nodes, centralized or remote. So if you have a 3-node cluster that you can SSH into, there might be a way to run one command and it will upgrade all of those nodes versus you having to SSH into each individual node, but we're still going to support that. The key thing here, though, is that the interface to this new kURL is a system D service. It's not kubelet and Kubernetes API server, controller manager, all this. It's a system D service, and we'll show that off in the demo too. Installations are a lot quicker. Instead of a large system that can take 15 minutes to install, right now, it takes about 2 minutes to install the first node and 2 minutes for each additional node. But more than just faster, we're actually streamlining the process. Before, it would take 15 minutes, and then your customer would be met with an upload the license screen. And now we're including the Helm chart and the license right in that binary that they download. So at the end of that 2 minutes, they're at a configuration page. They don't have to then figure out how to upload a license and go to the next step and air gap bundles and which application is it. It immediately goes to the configuration page. And then kind of a big one that I'm really excited about is the upgrade experience here. We're in the admin console with kURL 2 when the customer clicks an upgrade, because you shipped an upgrade to your application. If you also shipped an upgrade to the embedded cluster configuration, meaning you maybe went from Kubernetes 125 to 126, it will just handle that rolling upgrade. There's not two separate processes here. It's tightly coupled. You know that they're going to be running that version of your application on that version of the infrastructure. There's not two different commands that they have to do to run an upgrade. They just click one upgrade button. And even if it's a multi-node cluster, they click one upgrade button and we'll do the rolling upgrade across the nodes and then apply the application and handling the failure states appropriately. And the last one is that we do have a reset script. So this will be production supported. If you have something does go wrong, because you never know, it might be a firewall rule, or you find out that there's a hardware problem, we don't need to throw that VM away and wait for a new one to be provisioned. There's a reset script that will clean off everything, and we can start over fresh and reuse that VM. So it's going to be a little bit quicker for end customers. Upgrades. Absolutely, there's going to be an upgrade from kURL 1 to kURL 2 in place upgrades. So assuming, it's still, sufficient hardware to run it, and you'll be able to treat this the same way you would treat a Kubernetes 126 to 127 upgrade today in kURL. You'll be able to switch to kURL 2 in place, and we'll be handling that. And for anybody who's on the replicated native scheduler, an interesting thing that we have here too is we can actually do an in-place upgrade from the native scheduler, which is running Docker, to kURL 2. So if you have an application, you have it deployed, we're happy to talk to you about that. It takes a couple of little scripts that we can help you do, but we can do in-place upgrades, assuming that the hardware is capable of running Kubernetes. The timeline, I mentioned it's in preview right now. We're happy to share it. It has some limitations. It's under really active development. Would love to get feedback, use this. It's coming to production later this year, though. So at that point, we'll be able to support shipping it to end customers and supporting it. Right now, as a preview release, we'd love to hear how it's working and help control the timeline a little bit and be an early design partner with us on it. Given that, I'm going to hand it over to Chris, who's going to do a couple of demos here. We're going to try to do some installs, I think 2 or 3 different ways to show in the little bit of time that we have left and see if we can get it all done.